So today you're going to set up your lab. I want to discuss the warm-up in a second. You were all supposed to put together your own lab procedures so that you would know what you were doing today. And you should already know that you're not allowed to use the printed handouts. If you have those, make sure that they're put away. It's just a hassle because it wastes paper, but for the sake of consistency, I literally will recycle them if I see them, and I had to recycle a bunch this morning. So I want to answer the warm-up first, or rather I want to discuss the warm-up first. Who can tell me what happens when you put a freshwater fish in salt water? Has anybody tried this experiment?
Die.
Yes, they die.
Yes.
I've tried too. Right. But why do they die?
What if you put a salt water fish?
They also die.
Really? It is on the that.
Their gills will eventually start to weep a little bit of blood. It doesn't look so. It looks like a wound, I guess. But like if you've had like a fresh scrape and then you get in the pool or something, you can just kind of like see that like pinking of the water. It's not like they gush blood. Their gills seep. But why does that happen?
That's so terrible.
Yes. It's not the oxygen.
Just they have different gills and different like bodies that are used to.
They do have different like bodies and gills and whatnot. But what else?
I like these.
The fresh and the salt water makes a big difference. I want to remind you that if a fish is from fresh water, you can assume it has pretty close to 100% fresh water. Now, technically, I think everyone realizes that your bodies, just like fish from fresh water, have a bit of salt in them. So I'm cheating a little bit by calling it 100%. That's for the sake of demonstration, not actually correct. Yeah, it's not factual. But if the ocean is 3.6% salt, then please look up. You realize that it can only be 96.4 water, right? Because it can't be 100% water and salt. Again, 105%. So when we actually, I don't do anything. When Jack forwent the education he's paying for to do this work, we had to get about 950 mils of water and about the equivalent of about 50 mils of salt to make 100% volume of 95 water and 5% salt. Sort of like this. This is salt water and the fish is in fresh water. And so you can imagine that by unit of volume, the fish is a little bit more watery than the water outside the fish. That part's kind of crazy to think about. All the solids of the fish don't count. So inside the fish, its water concentration is actually higher than its surroundings. Does that make sense to everybody, that the water around it is not quite as watery as the water inside it? Strange concept, but the water around it has a bunch of salt in between the water molecules. If you lined up 100 molecules of salt water, there would be about 97 water molecules and about 3 salt molecules. So technically, the water in the fish is more watery than the water outside the fish. So does anybody know what that does to the fish?
Pressure problem?
Yeah, it has a pressure problem. And yeah, as a matter of fact, they do float a little more than usual. That's also true. But the pressure problem is that the water inside the fish wants to exit the fish to equalize with its environment. You may have heard of hypotonic, hypertonic, and isotonic. If you've ever heard about osmotic pressure. I believe you guys maybe have not because you don't take bio. Is that correct? Did take bio, okay. So you might remember the whole isotonic, hypertonic, hypotonic, osmotic pressure stuff. This is that conversation again. the water inside the fish will want to exit. And by the way, the salt outside the fish will want to enter. The salt and the water want to even out inside the fish as well as outside the fish. You know, if you guys were all crowded and I opened the door and there's some extra space, you would spread out a little bit. If I had just bunched all of these desks, you know, give it a couple days of school and you guys would kind of create the same spacing as everybody else around you. You would do this consciously because you're thinking about it. It's just an analog. But the water molecules inside the fish want to be just as crowded as the water molecules outside, and likewise the salt. Of course, your skin is pretty salt-proof. When you go into the ocean, you don't become a saltier organism. So you can put salt outside of you, and that cannot actually get through your skin. And lucky for all of us, our skin is waterproof. So we don't lose water to the environment unless we want to, usually. It's pretty darn close to waterproof. In a fish, technically, their skin is also waterproof. But poor little fishy, from its gills are not waterproof. And so coming out of the fish, through the gills, will be a lot of its water. Here's what's interesting. The salt cannot go into the fish. And if you assume it's in a large saltwater environment, adding a little bit of fish water isn't going to change the salinity of the tank. Does that make sense to everybody? It'll still be salty outside and he'll still be salt-free on the inside. So even though he's losing water, the concentration of water inside the fish is still 100%. Does that make sense to everybody? He's got less volume, but the concentration hasn't changed because he's not picking up any salt. Does that make sense to everyone? Mm-hmm. And the water outside might become 96.5 or 96.6 eventually, but probably not for a very long time. So the fish will literally dry out. You put a freshwater fish in salt water and you get fish jerky. I mean, not exactly fish jerky. But he'll keep losing water to his environment. You get a little fish raising. And this is exactly what happens when seedlings try to sprout in salt water. Your seed has, of course, it's like a sponge. It wants to soak up water so it can break its shell and sprout. But unfortunately for the seedling, as it's trying to soak up water and grow and burst through the shell, in a salty environment, it's losing its water. It's drying out. And this is why salt in soil prevents your seeds from sprouting. When you get to a certain level of salt, the seeds just can't absorb water enough to grow because they're losing it to the environment because the environment has a lower salt concentration than the seed itself. Yes?
How do saltwater fish die in freshwater?
And the opposite, they swell. So in that sense, I don't know, it must affect some function.
Yeah.
And by the way, it's not the whole fish. Remember that the blood inside the fish is actually where this action takes place, because this is a cellular process, not an organismal process.
Okay. So his organs aren't like being bloated, it's just his...
Well, the cells inside the organs eventually are the ones that either desiccate or overly hydrate, yeah. Mm-hmm. And so it's, I want to remind you that I'm discussing a cellular level, but drawing an organism. Mm-hmm. Everybody good with all this? Anybody want to ask me anything? Because I'm about to retire from teaching you today. Yeah?
Is there a certain way that we should like bunch the paper towel?
Oh yeah, I got you covered, bro. Yeah. You're going to make these. And you're going to bring them up to the front when you're finished. You'll start with plain lids and bottoms. Put a little piece of tape on the top so that you can label your percentages. Then, you'll pour off any extra water if you pour off from the whole pile, they'll all level to the same point because water's self-leveling. Everybody realize that? So you don't want to end up with one with a bunch of water and one with a little bit of water. That would be another variable, right? So we don't want to have an extra variable. We want to control for variation in water content in your Petri dishes. So when you filled all 6 of them, you'll hold them sideways and crack the lid so that they drain. But if you hold them all at the same angle, the water will level in all of them, and so they'll all have the same water in each of them. Does that make sense to everyone? Mm-hmm. Are you sure? Because you're going to put more water in the Petri dishes than they need. You're going to drown your seeds for a few minutes, soak the towels, and then drain off the excess so that they all have the same amount to remove that variable. So take a little piece of tape, and you'll wrap around the edges of your Petri dish like this. When you have all 6 of them, you'll use another piece of tape around them like this. Make sure you have your names and your period on them. Starting with a single paper towel, you fold, 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 and then trace the bottom Petri dish. Then you use cut, 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 cut to make a bunch of little rings of paper towel. Then you put 3 or 4, whatever, just be consistent, pick your number. But put the same number on the bottom and the same number on top of all your seeds. Flood them with stuff, drain off the excess, tape, 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 bring them up here. Clean up your tables and then you're done. Questions so far? I'll give you a tour of your facilities, and then you'll be starting. Make sure that the only thing on your table is the pre-lab.